Hello everyone. Today I am going to discuss the topic that is design process, software quality guidelines and attributes, and evolution of software design from chapter Design Concepts. Let us start with the topic that is the then each of the elements of analysis models provide information that is necessary to create the four design models required for a complete specification of a design. The data or the class design, that is the first one. It transforms analysis classes into design classes along with the data structures required to implement the software. Then the second one, that is architectural design. The architectural design defines the relationship between major structural elements of the software. Architecture styles and design patterns helps to achieve the requirements defined for the system. Then the third one, that is the interface design. It describes how the software communicate with systems that interoperate with it and with humans that use it. Then the fourth one, that is the component level design. It transforms structural elements of a software architecture into a procedural description of software components. So, all these are the different elements of the analysis model provides information that is necessary to create the four design models required for a complete specification of a design. Now, the next topic, that is design process. The design process comprises a set of principles, concepts, and practices which allow a software engineer to model the system or a product that is to be built. This model, known as the design model, is accessed for quality and reviewed before a code is generated and tests are conducted. So, the design model provides details about software data structures, architecture, interfaces, and components which are required to implement the system. Software design is a iterative process through which the requirements are translated into a blueprint for constructing the software. Initially, the blueprint depicts a holistic view of software. That is, the design is represented at a high level of abstraction, a level that can be directly traced to the specific system objective, and more detailed data, functional, and behavioral requirements. As design iterations occur, subsequent refinement leads to design representation at much lower level of abstraction. These can still be traced to requirements, but the connection is more subtle. Now, let us see software quality guidelines and attributes. McCullin suggests three characteristics that serve as a guide for evaluation of a good design. So, the first one, the design must implement all the explicit requirements contained in the requirement model, and it must accommodate all of the implicit requirements desired by stakeholders. The design must be readable, understandable guide for those who generate code and for those who test and subsequently support the software. The design should provide a complete picture of the software addressing the data, functional, and behavioral domains from an implementation perspective. Then, the next one, that is the design quality guidelines. In order to evaluate a quality of design representation, you and other members of the software team must establish technical criteria for good design. For the time being, consider the following quality guidelines, like a design should be modular, that is, the software should be logically partitioned into elements or subsystems. Then, a design should exhibit an architecture that has been created using recognizable architecture style or patterns. It composes of components that exhibit good design characteristics and can be implemented in an evolutionary fashion, thereby facilitating implementations and basically we can say the testing. Testing. Then the next one, that is having a design should contain distinct representation of data, architecture, interfaces, and components. Design should lead to the components that exhibit independent functional characteristics. Then, a design should lead to the interface that reduce the complexity of connections between the component and with the external environment. A design should lead to data structure that are appropriate for the classes to be implemented and are drawn from recognizable data patterns. A design should be represented using notations that effectively communicate its meaning. So, a design should be derived using repeatable method that is driven by information obtained during software requirement analysis. So, using notation, that is very important. Then, Hewlett Packard developed a set of software quality attributes that has been given the acronym like FURPS. F is the functionality, U is the usability, then R is reliability, P is performance, and S, that is the supportability. Then the next topic, that is the evolution of software design. Basically, a software evolution is a term which refers to the process of developing software initially, then timely updating it for various reasons, that is, to add new features or to remove absolute functionalities, etc. In software engineering, software evolution is referred to as the process of developing, maintaining, and updating software for various reasons. Software changes are inevitable because there are many factors that change during the life cycle of piece of software. Like I can say, some of these factors include requirement changes, environment changes, errors or security breaches, new equipment added or removed. Then we can say improvement to the system. So, the evolution of software design is a continuing process that has now spanned more than 6 decades. Early design work concentrated on criteria for the development of modular programs and methods for refining software structure in a top down structured manner. Newer design approaches proposed an object oriented approach to design derivation. More recent emphasis is in the software design has been on software architecture and the design patterns that can be used to implement software architecture and lower level of design abstractions. Growing emphasis on the aspect oriented methods, then model driven development and test driven development. All these emphasize techniques for achieving more effective modularity and architecture structure in the designs that are created. The number of design methods growing out of the work just noted are being applied throughout the industry, like the analysis method presented previous chapters. Each software design method introduces unique heuristic and notation, as well as uh, somewhat we can say the parochial view of what characterizes design quality. It All of these methods have a number of common characteristics, like a mechanism for the translation of the requirements model into a design representation, a notation for representing functional components and their interfaces, heuristics for refinement and partitioning, and guidelines for quality assessment. Regardless of design method that is used, you should apply a set of basic concepts to data architectural, then interface and component level design. These concepts are considered in the sections that follows. So all these about the evolution of software design. Hence, we can say the evolution of software design follows the top-down structured. It's in the top-down structured manner. Then the object-oriented approach. Then its emphasis is on the aspect-oriented methods, model-driven development, and test-driven development. Also, we can say it's a unique heuristic and notation. Then the next one that is very important, that is the characteristics of the design method. So the first characteristics, that is mechanism for translation of requirements model into a design representation. Then the notation for representation functional component and their interfaces. Heuristics for quality assessment is required. Guidelines for quality assessment, that is also one of the characteristics of your design method. Thank you.